if I go to this, or if I okay, but then I want to write. Okay, I'm live again.
Hello.
I'm live again. I need to work out how this works, and that might be done through a series of private streams, where I try different things out. But okay, I'm back live again. Hello again. This time we're actually going to do the study with me part of the study with me. Yeah, I pretty much give up with that, trying that, because I mean, okay, it is a good idea if it's gonna work. Привет, как дела? He says, pretending to be Russian. Okay. Let me see. Let's set myself up here and get back to what we know and love. So, this is actually work that I have to get done. So, yes. There we go. Hopefully you can see that. Where did I get to this morning? I did the first double-sided page. So, I might move this up. Zooming out. Okay, that means I am ready to start, and then I can edit the thing. Sorry with me here. Chemistry edition. And this one is not entertainment, it's education. Save. So you don't understand. Yet chemistry is very confusing. Like, extremely confusing. Okay. It is often possible to distinguish between organic infrared spectroscopy or why is it difficult to distinguish between butanediol and 2-methyl propanediol using infrared spectroscopy without access to a database? It's because they will both show similar troughs. Due to OH groups and CH bonds. However, the fingerprint region will be different. However, this cannot tell us what the molecule is. I studied chemistry, biology, maths, and further maths. This region cannot easily describe or cannot easily... I know what I'm trying to say, it's just hard to say. This region cannot easily this region cannot easily tell you, looking for that, tell you what the molecule is. There we go. Привет, Dan. Molecule is without comparing. Basically, what I tried to say is those two, butanediol and 2-methylpropanediol, both have the same bonds in them, but they'll have a different fingerprint region, and so you can't tell what they are except for that. On je voi держал płytki ruskim языком. No idea what you said. Sorry, org. Okay, butanediol and 2-methylpropanediol give the same observations and reacted with phosphorus pentachloride. Write an equation for 2-methylpropanediol with phosphorus. Right. 1, 2. That's actually very easy. OH. Plus PCl5 goes to H3CCCH3CH3 Cl plus POCl3 plus HCl. Jude, I'm so proud for you. Thank you. Do you like my pronunciation? Okay, name the organic product. 1, 2, 3. So it's going to be 2 chloro, 2 methylpropane. Мы сейчас не выдержим путь к химии и английским. Okay, describe how you would use simple test reactions to distinguish between butanediol and 2-methylpropanediol reagents, conditions, observe. How many marks is this? 6. Nope, thank you. Bye, really. Oh wait, hold on. Is this the iodoform reaction? Because iodoform is not on my spec anymore, so therefore I don't have to answer the question. Haha. I'm trying to think. Do I know any reactions that? Oh, you could oxidize them, because that won't get oxidized, but that will. Let's talk about oxidation, because that's a secondary and that's a tertiary. So, okay, let's go for butanediol first. Add 5 centimeters cubed butanediol to your test tube. So hopefully I'll be able to teach you some chemistry from this. So we're going to add some butanediol, which is just a chemical. I'll draw it if I have paper. So butanediol is a chemical, and butanediol looks like butanediol. Butanediol looks like this. We have all our H's, we have an OH. So anytime, not Duolingo, yes, on Duolingo. So anytime I mention butanediol, this is what we're talking about here, okay? I'll leave that here. So anytime I talk about butanediol, that's what we're talking about. And add potassium dichromate. reagents, conditions, chemistry. I said add potassium dichromate. Amelia's gone now. Amelia left my room. Add potassium dichromate. Add let me see, what acid shall we go for? Sulfuric acid. To acidify. Chemistry is really interesting. Add sulfuric acid to acidify. And so what's going to happen is the butanediol is going to turn into, what is the, I don't know how you call it, ketone, like butyl or something, and then acidify. Your opinion that chemistry is really interesting is really biased. Haha, true. Add sulfuric acid to acidify, and the butanediol will be oxidized. Potassium dichromate will turn from orange to green. So there's reagents, there's conditions, observation is there. Amelia hasn't actually done much chemistry, so we are, basically what we're doing is we're adding something called an oxidizing agent. In other words, just call it oxygen, and you end up getting this here. Oh, I know what it's called now. So we're changing butanediol, and instead of this, we're gonna delete this here. We're gonna add this here and make this into an O, and this is called butone. Yes, butone. Or just butone, because you call it butone. Because that could be there or there, and that wouldn't change it at all. So butone is the name of that. Potassium chromate will turn from orange to green as we're going from K to CR2O7. If we move that, that's 2 minus. I need to work out what the butadiol is an alcohol. It is true. But we're using this is butanediol. Butanediol would mean there would be an alcohol group here and here, or here and here, or here and here, I suppose. So K2CR2O7. If I can talk, so these are +1 times 2. These are -2 times 7, so that's -14 there. -14, 13, 12, so each one of these is +6 times 2. As CR6 plus is reduced to CR3 plus. This is chemistry, and it is homework. It's reduced to 3 plus. And what else are we forming? We're forming water. So that just kind of happens. And basically, how does that work? If you have do this C just to make it look easier. Pretend at the end of all these things there are hydrogens. Right, that is just that rewritten. You're gonna get, I love chemistry, so this is so interesting, I think. If we have this thing called our oxidizing agent here, it's gonna come and be like, yum, mine. They're gonna go into that, and then there's this thing here goes down to here, and you get that. Just makes me really happy. So that just steals 2 H's off it, and then there's an extra line going to the O. Okay, now that is how to distinct, that's how butanol. Then if we go to our 2-methylpropanol, add 5 centimeters cubed. Oh, or do you want me to use the latanic names? Okay, so carbon and hydrogen. If I'm writing out organic things, I'll just call them C's and H's, but it is carbon and hydrogen. Add 5 centimeters cubed. What are we using? 2-methyl. 2-methyl. Propan 2. Oh, Nikita, do you want me to say hello to you in Russian? Привет, Nikita. Or I could say Здравствуйте, Nikita. Okay, add 5 centimeters cubed of 2-methyl propanol to a test tube, and add potassium dichromate. Aha, new page. Add sulfuric acid to acidify. And no reaction should occur. As tertiary alcohols do not undergo oxidation. So why do tertiary alcohols not undergo oxidation? This is class for today, guys. Okay. So if I draw out 2-methyl prop and 2-ol, it looks like C H O H. Oh no, there should be CH3 here, and then we have CH3 and H3C. Yes, Patrick, you finished your history. Alcohol rocks and alcohol you. So this is what 2-methylpropanol looks like here, and if we want to try and oxidize it, right? As you saw here, the oxygen here takes a hydrogen and another hydrogen off the carbon and off the O attached to the carbon. So if O comes in here, oxidizing agent thing, it can take this H here, but there's no more H's attached to this carbon, and so it cannot get a second H, therefore it doesn't get oxidized, and you can then tell the two things apart. Let's continue. Okay, isopropyl alcohol. Oh guys, this is relevant. This is extremely relevant. Hand sanitizer. Hand sanitizer. See, like Latinic C needs, not like English C. What do you mean? Do you want me to say K? Here we go. This is just like what we've turned into now. This is isopropyl alcohol. Okay, hopefully I zoomed out again. We use ethanol mostly as hand sanitizer. We use isopropyl alcohol. Or, yeah, isopropyl alcohol. Okay. And it cleans it. We're going to give the IUPAC name for isopropyl alcohol. 1, 2, 3. Propanol. Propan-1-ol is a structural isomer. Explain this term. A structural isomer is a molecule with the same molecular formula but a different structural formula. Job done. Oh no, ethyl methyl ether is the structural isomer of isopropyl alcohol. Why is the boiling point of this lower than isopropyl alcohol? So isopropyl alcohol contains a polar OH group. Which can form hydrogen bonds. Increasing its boiling point. Ethyl methyl cannot form hydrogen bonds. Ethyl methyl ether cannot form hydrogen bonds. No. And so has a lower boiling point. That's that page back. Okay. Isopropyl alcohol can be oxidized using acidified potassium dichromate. Can I zoom out again? Because that'll be very... There we go. Is my work efficiency decreasing during the live? Kind of, but it's more fun. Usually I would like fly through these questions, but I don't mind. It can be oxidized using acidified potassium dichromate. 6. Draw the skeletal formula. Oh, nice. And this is a ketone. Because it was a secondary alcohol that made it. Okay. Explain how infrared spectroscopy could be showed to show that the oxidation reaction was complete. The trough, due to the OH group, on the left hand side, trough on the left hand side, the OH group would disappear. And a trough due to the C double bond O would appear. Oh yes, we have a calculation. So we're going for isopropyl alcohol to what is that called? Propanone. 1.5 grams to 1 gram. Isopropyl alcohol. 12 times 3 plus 1, 2, 3, 4, 5, 6, 7. Yet. 16. 1, 2, 3, 4, 5, 6, 7. 8. Oh, 0.025. Eat that over here. 0.025 and then prop unknown. All you're doing is taking away a hydrogen and an oxygen. Or 2 hydrogens. So it's going to be, instead of 60, we're just going to decrease this to 6 and it's going to be 58. 1.45 should be formed. So 1.45 under 1 times 100 gives us our percentage. And the percentage is 68.96, which will round up to 69. Nice. Isopropyl alcohol is completely soluble in water. Explain. The OH group can hydrogen bond Caspian, I want to do drug research. So I want to like find new drugs, find new medicines, etc. like that. I can find like what they are and how to make them. That's kind of what I want to do. Can hydrogen bond to water molecules? As it has and like dissolves like. Like they're both polar. Suggest why the addition of sodium chloride to an aqueous solution of isopropyl alcohol causes the alcohol to become less soluble. Sodium chloride, well, we're going to be forming, we're adding Na pluses, but we're also adding Cl minuses. So it's going to be forming, what's it going to be forming? It's going to be forming this thing here. Or is that basic? Is it going to be forming this, or is it going to be forming a Cl? Oh, maybe it's because the the ions Na plus and Cl minus dissolve preferentially. dissolve preferentially in water over the OH group, and so it is less soluble. Yes, alcohols do have OL endings such as ethanol, propanol, methanol, or also isopropyl alcohol. Haha. Hypochlorous acid has a formula Huckel. It adds to alkenes to form chlorohydrins. Okay, nice. Calculate the enthalpy change. I love that. Enthalpy change, great. So on the left hand side we have C11C, and then we have 4 C single bond H. We also have H, O, and OCl. And this is 612 C single bond H. I'm missing C single bond H. Oh, we're just using hypochlorous acid, but there's still. Where's the C single bond H? Or is it just because it's the same on both sides? There are 1, 2, 3, 4, 1, 2, 3, 4. Okay, but there's no H's in this at all. I am highly confused by this questions. Because, right, well there's 4 H's, so we'll ignore that. If there's an OH on this side and an OH on this side, so we'll ignore that. Which means it's 612 plus OCl, which is 272. So this is 884. That's how much energy is required to break those bonds. And then right hand side, which means heat is taken in to break those bonds. On the right hand side we have C, Cl, we have C single bond C, and we have C single bond O, and we just have one of each, so we have 347, 346, CO 358. Which gives us 10,051, and whenever bonds are made, energy is released. So it is going to release so when bonds are broken, energy is used. When bonds are made, energy is produced. So then we have 106 plus 167 is our enthalpy change. Okay, now we have one of these diagrams. Right. So then this is going to be, I suppose, what do you call the thing? What are we making? Calculate the enthalpy change for the reaction between ethane and hypochlorous acid. Yeah, okay, I've done that. I'll just call it chlorohydrin then. Or we'll say reactants. Products. This is the activation energy. This here. Activated complex. And then we're going to call this minus 8 for. Oh, then this here is delta H. And we have 1051. And we have 884. And delta H equals 167. I probably got that wrong, but you know, we tried. Okay. Hypochlorous acid has like his polar bond, yes. What is that between polar bond? There's uneven sharing of electrons. Because one atom has a lower electronegativity value. Draw the polarity of a hypochlorous acid molecule. There we go. Draw the mechanism with curly arrows, the reaction of hypochlorous acid with propane to okay. So it's nucleophilic attack. Because you started studying Russian is hard, but it is so difficult. We're going the wrong way about this, aren't we? This should be Cl HO. Delta positive. You're delta negative, and so that goes into that. And this is going to go into this. These are so confusing. Yeah, it's the electrophilic condition. So that going into that, and then the next part is C HCl C. Oh, I forgot what there's another CH3 here. C CH CH plus OH minus. They're going to go up to there. We finally get H CH CL CH OH CH. Zurich is not so difficult, only a soft sign and hard sign. Name the compound. 1-chloro propanediol. Last page, and then I'm actually going to stop the stream because I am exhausted. Is the major product. Draw the structure of the minor product and explain why it's the minor product. Okay, this is the minor product. Because Markovnikov rule states that the negative molecule, we'll say molecule, will add on to the carbon, well, not add on, we'll say bond, to the carbon with the least amount of hydrogen attached. This is more stable. As it has 2 electron donating alkyl groups. In the reaction, products carried out in sodium nitrate. Okay. Part 3. Where is part 3? Okay, we're doing the mechanism. Yeah. This thing is formed. Suggest how it is formed. So if I will draw this out because it helps see H Cl CH NO2 CH. So we're having the Cl and the, wow, this is interesting. But we can speak with you. We can talk with you. What do you mean? Oh, ESC pull an egg. ESC pull an egg. I will talk to you. Except I'm also doing chemistry in a minute. So just how this is formed. Well, what's different this time? The OH group is going to react with the sodium. The OH bonds to the Na. To form an OH. And the NO2 minus. Bonds preferentially to the carbocation. Chlorohydrons are very useful in synthetic chemistry because they're bifunctional. They have two. They have two functions. I don't know. Complete the following reaction scheme. Oh no. PCl5 converts any OHs to Cl. So we have CH, H, Cl, C, H, Cl, C, H, H, H. Fun. Then with KCN, we're gonna get. Wait, what does CN do? It replaces OH with CN. Cl, C, H, CN, C, H, H, H. We have a nitrile here. NaOH. Aqueous, which means it's basically Na. So this is just Na plus ions then. It's going to go for CH, Cl, CH, O minus Na plus, CH, H, H. And finally with HBr, H, C, H, H, Cl, C, H, Br, C, H, H, and H. What a way to end this chemistry paper. What to the calculator? It's a Casio FX CG50, which I got as like a welcome to lower 6 present. I bought it. Okay. Let's flip the camera. I exist as a human. Oh, what am I doing? I didn't even know that was a thing you could do. Are you going to see that on the screen? Because, oh, it's food time for me. Cl is chlor. Yeah, genau. It is time for me to eat. Goodbye.
Are you done?
There is no button to stop. What? And, okay, goodbye. I have to go to eat. Goodbye.